I am the Mars Atmospheric Global Imaging Experiment PI on the 2016 Trace Gas Orbiter. I am from Malin Space Science Systems. We're a small company in San Diego, 20 years of hardware experience. We do imaging system development, mission operations, and science data analysis. We have a pretty good track record. We have 34 plus instrument years of deep space operations, and we currently have 7 different MSL cameras operating on spacecraft orbiting 3 different planetary bodies at this time, with 2 more this year with Juno and MSL launching. We built 20 flight instruments on 12 missions and have collected over 700,000. We have commanded over 700,000 images and downlinked those, and have over 300,000 hours of instrument operations. So we have quite a bit of experience, and we'll be extending on this. This is the TGO spacecraft, which is a joint mission with ESA. Here is the MAGIE. We're kind of dwarfed by all the other instruments on the spacecraft. This is their landing, test lander they have, and this is the MAGIE instrument. MAGIE is from a long line of wide-angle cameras that have been built by Malin Space Science Systems, from Mach to the MCO orbital camera to Marcy on MRO to LROC wide-angle camera, and now the MAGIE. We have a fairly large international diverse science team. I like to say our international partners. These are all the free guys that we get on the team because we don't have to pay them. So our U.S. side is fairly small, so that keeps our costs down. MAGIE consists of a single camera head with dual optics for the UV and the vis, and a digital electronics assembly. We're on the order of just a couple, less than 3 kilograms. We're doing overall instrument management, all hardware and software development and design and build in-house at Malin Space Science Systems. A couple subcontractors. We have a lot of heritage on this spacecraft, and that's why we were selected. From MRO Marcy, though we have a smaller field of view, basically the same camera head design. Electronics from MSL, a turntable from the Mastcam fifth wheel MSL, and the digital electronics assembly also from our MSL instruments. The investigation that MAGIE will be carrying out in association with the other instruments is we'll be providing global context imaging, synoptic weather monitoring of the full day side of the planet on each orbit, to provide context for the trace gas experiments. We'll also measure the CO2, water ice clouds, condensates, and dust, and we also have the capability to look at the trace gas ozone. At the 400-kilometer altitude, the spacecraft will have a ground sampling resolution of less than 500 meters at full resolution at the nadir, which is twice the resolution, higher resolution than any previous wide-angle camera sent to Mars. And we're about 2.5 kilometers on the limb. Operations, again, day side of the planet, will be on basically just before we get to the terminator and just after we pass the terminator on every orbit. We're a push framing system as previous wide-angle cameras. We have a lot of experience with that. That works very well for these experiments. On this one, we've gone a step further, and we have a turntable on the camera to compensate for the yaw of the spacecraft. This allows us to actually turn our instrument so that the long track direction of our detector is along the velocity vector of the spacecraft, and this allows us to do mission phase function observations. Fortunately, this is at the loss at the expense of the daily global mapping coverage, but from this, we can provide visible optical depths of water ice clouds and dust, particle sizes, and the single scattering phase function of the aerosols in the atmosphere. Science objectives. Again, we're going to provide the meteorological context for the other trace gas instruments. Look for localized sources of sinks and for the aerosols. We're going to map the occurrence of ozone, provide geological context for trace gases, and as secondary is to extend the daily global mapping coverage that was begun by the MGS MACH in 1999. We've had continuous daily coverage since then, so we're over 6 Mars years of weather. So we're actually, if MRO continues and MAGIE gets to Mars safely and operates, we'll be into basically just about our second decade. We'll be going into our second decade of weather observations, which at that point we can actually start talking about climate. Instead of just modeling it, we can actually talk about the real thing. And we will provide meteorological support for future missions. So just some pretty pictures I want to show that we can actually map water ice clouds. This is from the MRO Marcy on a daily basis, and we can actually look at dust storms and water ice clouds. And these are important because the distribution of the atmospheric trace gases are controlled by meteorological conditions, so it's very important to provide the daily global coverage. We're actually the only instrument on a spacecraft that provides true global coverage of the day side of the planet. We'll map the occurrence of atmospheric ozone. This is just a summertime map from the Marcy UV camera, where the bright colors are actually high concentrations of ozone mapped in Hellas Basin in the North Polar region. Ozone is important. It's a reactive constituent in the Martian atmosphere, which controls the UV flux that reaches the surface. It's a tracer of photochemistry and highly relevant to overall trace gas research. I'll go ahead more. We're going to provide context for the trace gas observations. These are this is basically what the MAGIE daily global mapping resolution will look like. This is our Sea of Mons, and there's these little dust plumes kicking up on a plateau on the southern slopes. And this is what the view will be in the context image at full resolution. We have the ability to bring back low resolution data, and then if we see something interesting, command back the full resolution data so we can do post-imaging targeting. So we'll basically not miss any interesting atmospheric events. And here are the plumes on the slopes here. The possibility of active volcanism or hydromagmatic processes, geysers basically. It's a long shot that we've seen anything like this. We haven't seen anything to date in any of the orbiter missions, but if something was to be observed, we'd be able to bring back context imaging of this to help the trace gas instruments to target these regions later. Here's a pretty map. This is the kind of daily product we'll bring back every day to the project, and these will be distributed actually to the community on a fairly short time scale. And we'll also be providing meteorological support for rovers. We've been doing that for MER on a daily basis, and we've actually provided enough support and lead time in the observations of a number of dust storms that we were able to provide them enough, the MER mission, enough lead time that they can shut down the experiment. We've actually extended the life of, well, unfortunately Spirit is now gone, but we were able to extend the mission because we were able to forecast a dust storm moving over the region in 2008. So we plan to do that for future rover missions and all lander missions. And that's all I have.